Same way we have boosting strategies. So in boosting, let's start with AdaBoost. So in bagging here, we saw that all of these models are independent of each other. Since all of them are independent, so what you need to do is you need to find out which model supports parallel processing. Second boosting algorithm, which is GBM. So basically your error is y minus y cap, even. Yes, again, model 3. Now, if I combine these equations, just combine all these equations, what will I get? You will get some output. Final result is the addition of that output. Same way we have boosting strategies. So in boosting, let's start with AdaBoost. So boosting the principle, I'll tell you what's the principle of boosting. Principle of boosting is next model learns from the mistake of previous model. So in bagging here, we saw that all of these models are independent of each other. Okay, they are just like they are not dependent on decision tree 3 is not dependent on how decision tree 2 works and so on. Like they are all independent. They are a random sample taken model trained. That's all. Boosting is a bit different than boosting. And mostly all of these algorithms are tree-based algorithms only. The ones that I'm talking about today, they are tree-based algorithms. And a lot of interview questions related to machine learning are asked from these only, from bagging and boosting. Okay, especially tree-based algorithms. So if possible, like after today's class, try to read more blogs, get more theoretical knowledge on implementation also. Like how can you fast this? Like what's the difference between bagging and boosting? So since all of these trees are independent, what can you do? Like what can you think of to making it fast? Since all of them are independent, we can easily parallelize these. Okay, like we can just train all of these 100 trees parallelly. Okay, not 100, but let's say maximum workers, we can say 10. So each worker is training a decision tree. Okay, so we can do things like this, and we can do it internally. Like nowadays, models are capable of doing that. Models have parallel processing inside them. Okay, so things like these. So what you need to do is you need to find out which model supports parallel processing, because that will be faster for training and so on. Okay, so yes. So coming to boosting. Now boosting is independent. Like sorry, boosting in boosting, the next model that is trained, it is dependent on the previous model because it learns from the mistake of previous model. Okay. Now in boosting also there are different algorithms. Like first one is AdaBoost. Okay. What is AdaBoost? So let's say you have some points. Okay. Points like these. So what will happen is you will train your first model on this data. Okay. So how many points are there? Let's say there are 20 points. Okay. And out of these 20 points, 15 are predicted correctly and 5 of them are predicted wrong. Let's say these 5 are predicted wrong. ये जो center के 5 दिख रहे हैं, यहाँ पे wrong prediction हुआ. Okay. Now what next model will do? How the data for the next model will look like? कौन से ये 5 तेरा? This is how the data for the next model will be. What do you see? What's the difference? Larger in size, as in we give more weightage to the wrong points. That means wrong weightage means that how usually we calculate this. Loss function कैसे calculate करते हैं? It's summation of y minus y pred का square, right? This is for regression. For classification we are talking about. Sorry. Do you guys remember for classification? For the one we discussed in logistic regression? 1 by n log y log plus, and this is whole negative, plus 1 minus y log 1 minus y hat, right? So this formula, this is for a single point, correct? This is a single point and we calculate this for all the points and we sum it up, correct? Now what do we do? For these 5 points, let's say I have set weight equal to 5. So what it will do is it will just multiply 5 for these points. For the remaining point, it will be same. But for these 5 points, it will be 5 multiplied by 5. So what does the model learn from it? Model learns that whenever these points are classified wrongly, I am getting a high error. So while correcting for these points, these are contributing more towards gradient descent, right? These points, when these points are predicted wrong, they will contribute more towards the change of weights. Change of weights as in change of thetas. Getting my point? And in decision tree, if we think with respect to decision trees, these points should be more pure. Like these points should be prioritized to present in a separate leaf nodes. Okay, because they are of higher weightage. Is this clear, guys? Or to explain it very simply, like to be more generalized, just put 5 points. So here it was 1 point previously. Put the same point 5 times. So it will be generalized for all the algorithms. You implement decision tree, and you will see just replace this single point with 5 same points, and you will get your answer. What I'm trying to say. Okay. So now basically the algorithm will be trained in such a way that these points will be isolated. So this algorithm will mainly focus on these 5 points. Of course, other points are also there, but these 5 points will be focused, will be the area of focus. Okay. So this time, let's say our accuracy reduced 13 points correct and 5 points wrong. Sorry, 7 points wrong. But these 5 points will be in the correct category. Okay, that's the focus. Now, these 7 points will be highlighted for model 3. Okay, and so on. So this is how decision tree, this is how AdaBoost works. Any doubt in AdaBoost, guys? Now, second question, how can you make this fast? Here, the models are trained sequentially. How can you make this fast? Let's say we are using decision tree. Simple answer is if we can speed up decision tree. Now, question is, how can we speed up decision tree? So, guys, each split is independent. So, first split. Now, these two nodes are created. Now, these two nodes are independent of each other. You can split them together parallelly. It will create these 4 nodes. Again, these 4 nodes can be split parallelly and so on. Getting my point? So the time taken for the tree should be equal to number of levels you are going in the tree. If your tree is 10 levels depth, so it's 10 times time taken to a single split, time for one split. So if you make your decision tree fast, automatically all the algorithms becomes fast. But yeah, of course, this is again a separate reading topic, like how can we make AdaBoost or whatever algorithms faster? Okay, what parameters can be used to make these faster? But I guess in AdaBoost, there was no such thing, but the advanced version of these boosting algorithms that later came in. For example, Light GBM. Light GBM was one of the algorithms that support parallel processing internally. Okay, so things like these. But any doubt in the core algorithm, guys? Any doubt in AdaBoost? So this is one thing. Then comes to second boosting algorithm, which is GBM or gradient boosting machine. Okay, how does this work? So let's say you have your data called x1, x2, y. This is your original data. Now you will train model 1. Okay, your model 1 predictions are y cap. Okay, so basically your error will be error 1 will be y minus y cap. Yes, or you can say y equal to y cap plus error. So basically your error is y minus y cap, even. Is it clear till here? You have x1, x2, you have to predict y. You train model 1, your predictions are y hat, and your error is even. Even is y minus y hat. Model 2, this will be your data for model 2. x1, x2, and even. Your predictions. So what is even? Even is the error of model 1. Your prediction will be even hat, and error 2 will be even minus even hat. So if I rephrase this, yes, again, model 3, x1, x2, and x1, x2, and what will model 3 predict, guys? Are you guys getting the gist of this? What is model 2 trying to predict? Come on, don't hesitate, guys. It will be a wrong answer. So that's it. Like this is how like all the models are trained. Now, if I combine these equations, so I'll write the equation here. Like error 3 will be error of this model. It will be actual error of model 2 minus predicted error of model 2. Okay, basically E2 will be E2 hat plus E3. Now, if I combine these equations, just combine all these equations, what will I get? So first equation, main equation is y equal to y hat plus E1. Now, what is E1? E1 is E2 plus, E1 hat plus E2. What is E2? E2 hat plus E3. So you are getting it, right? So you have an input. Let's say you have input x1 and x2. You give it to all the models, model 1, model 2, model 3. You will get some output. Final result is the addition of that output.